At Epec, our family of companies are committed to the mission of pioneering and adapting to the latest manufacturing techniques, while also being a leader in quality and reliability. When it comes to making our premium circuit platforms, one of the challenges to this mission has been ensuring even hole plating when the hole aspect ratio is very high. Before we get into what this means for manufacturability, let's first explore aspect ratios. If you have ever configured the screen settings on your computer, television, or other electronic display, then you are probably already familiar with the term aspect ratio. For example, you may notice how smartphone cameras typically format photographs with the low aspect ratio of 9:16 or 9 pixels in the horizontal direction for every 16 pixels in the vertical direction. While this may fit the display for a smartphone perfectly, computer monitors tend to be much wider than they are tall, so the higher ratio of 3:2 is preferable for the picture shown here. Speaking of this picture, it is a section of an HDI, or high-density interconnect, designed for soldering an integrated circuit with BGA, or ball grid array, surface mounts. If you look closely at the image, you will notice that most of the copper teardrops covered by the solder mask have smaller circles in the middle. These are actually drilled holes that we have plated until the holes sealed up, since they only carry signal, without needing an aperture to house component legs. This is important because, at 0.06 of an inch, these are typically the smallest diameter, mechanically drilled holes found on a circuit board. Some of the holes go all the way through the entire thickness of the board, making them much longer than they are wide. Assuming that the 6 mm hole is 60 mm long, then the aspect ratio for this via hole is found by dividing the thickness of the board by the diameter of the hole, which comes out to 10. When this ratio is above 10/1, physics causes typical plating techniques to become less consistent. Plating shut is one thing, but plating the whole wall up to a desired thickness is more demanding. Imagine trying to shoot an arrow through several rings in a line. Even if you found the best archer in existence, the laws of physics are going to have an impact on the difficulty of this challenge, as various factors start to change. Especially if you decrease the size of the rings, or increase their count. Now imagine, if you will, that the rings are actually drilled holes in the starting copper canvas that we call a panel. In this case, the arrows would in fact be more like a flowing fluid, intended to permeate the panel through the holes. The reality is that conventional metal plating methods are typically a wet process, meaning that they take place in liquid baths. Don't worry, although fascinating, you do not need to know the chemical reactions associated with the electrolysis process, or understand the electrical deionization involved with electrolysis. The truth is that the issue is really much simpler than the complex atomic science involved. To put it quite simply, the plating process only works when the fluid in the baths can flow freely through the holes. Customized geometry of our reverse pulse tanks, a collection of specialized recipes, and regular maintenance of the pumps, filters, and agitators are just some of the ways that our highly experienced team has invested towards having the best metaphorical archer known to man. As a result, we are able to guarantee consistent hole plating distribution for circuit boards with aspect ratios at the bleeding edge of technology. However, similar to the way that gravity would cause arrows flying through rings to fall, deflect, and eventually lose momentum, fluid mechanics will act to restrict flow. And poor flow means suboptimal plating. And suboptimal plating means that the board will not pass quality inspection. Now, believe it or not, there is a popular children's toy that illustrates how this obstacle is created. A bubble wand works by combining the surface tension found in watery solutions and the adhesive forces behind capillarity to stretch the liquid across a ring. If you are familiar with this toy, then you may have noticed that the larger rings require less force to produce a bubble. This is because the forces bonding the fluid to itself are much weaker than the forces that make the fluid stick to another surface. Larger diameter rings require more cohesive links, which means a weaker chain of the forces preventing flow. Or maybe you also noticed that the film of fluid forms more easily on the smaller rings. Unfortunately, something similar happens in our tanks, and the result is not as fun. Fluids and gases tend to want to stick around more when the holes are small. At Epec, there are not many challenges that we are unwilling to undertake. However, we want your mission to be successful as well. For this reason, we try to ensure that our partners are aware that it is best to keep plated hole aspect ratios at or below 12:1, wherever possible. And if you want to see more videos from us, remember to subscribe, like, and also follow our blog for regular updates.